Imagine you're standing on a surface so hot it would melt lead in seconds. The ground beneath your feet is ancient beyond comprehension, pockmarked by billions of years of violence. Every crater a scar that never healed. Every ridge a wound from an impact so massive it reshaped the landscape for thousands of kilometers in every direction. The rock beneath your boots is gray-black and powder-dry. There is no wind. There has never been wind. There's no sound at all. Nothing rustles. Nothing moves. The silence is so total. It has a texture. Above you, there is no sky. Just black. Just stars, burning with an unfiltered fury you have never seen from Earth. No atmosphere to scatter the light into blue. No clouds. No horizon haze. Just a raw vacuum of space starting a few centimeters above the ground. And ahead of you, the sun. Not the soft yellow disk you know. This sun is enormous, swollen, filling nearly 3 times the width of the sky compared to what you see from home. You can see granules on its surface. Vast convection cells the size of Texas churning in slow motion. Its light does not warm you. It destroys you. Every photon arriving here has traveled less than a third of the distance it travels to reach Earth, and arrives carrying the full, unfiltered, unshielded force of a star just 57 million kilometers away. The radiation dose hitting your body right now would be lethal within seconds. And yet, here is what would genuinely disturb you. More than the heat, more than the silence, more than the radiation tearing through every cell in your body at this very moment. You would be standing on a planet that scientists spent centuries dismissing. A planet they call barren, dead, boring, a relic, the cosmic equivalent of something that used to matter before time moved on without it. And they were wrong about almost everything. Mercury does not look like a threat. From a distance, it looks like our moon, small, gray, scarred. It is the smallest planet in the solar system, roughly 4,879 kilometers across. You could fit 18 Mercuries inside Earth. It has no moons of its own, no rings, no real atmosphere to speak of. For most of human history, we could barely see it. Mercury hugs the sun so closely that from Earth it only appears briefly, just after sunset or just before sunrise, always hiding in the glare. Ancient astronomers actually thought they were seeing 2 different objects. The Greeks called it Apollo in the morning, Hermes in the evening, before realizing it was the same world. We did not get a close look until 1974, when NASA's Mariner 10 flew past and sent back the first real images. What scientists expected to find was exactly what the moon looks like, a simple, dead, cold rock, predictable. What they found instead began to quietly unravel everything. Mariner 10 detected something no one was prepared for. A magnetic field. Not a relic, not the ghost of something ancient. An active magnetic field, generated from within, exactly like Earth's. This should have been impossible. Magnetic fields like ours require a molten metal core churning constantly, producing what scientists call a dynamo. But Mercury is tiny. It should have cooled and solidified billions of years ago. By every model available in 1974, this planet should have been magnetically dead. It was not. And that was just the beginning. For the next 3 decades, Mercury sat at the edge of scientific understanding, too difficult and expensive to reach for a proper mission. Getting to Mercury requires extraordinary fuel to fight against the sun's immense gravity. It is, paradoxically, one of the hardest planets in our solar system to reach, despite being one of the closest. Then, in 2004, NASA launched Messenger, the first spacecraft designed to actually enter orbit around Mercury. It arrived in 2011 and spent 4 years circling the planet more than 4,000 times. What Messenger found changed the field of planetary science permanently. Let us start with the one fact about Mercury that scientists still struggle to fully explain. Its core. On Earth, the iron core makes up roughly 15% of the planet's total volume, a solid inner core surrounded by liquid outer iron, the engine of our magnetic field. On Mercury, the core makes up 85% of the planet's radius. Let that settle for a moment. Picture an orange. Now imagine that nearly the entire interior of that orange, right up to the thin skin of peel, is solid and liquid iron. What you think of as the planet, the surface, the rocks, the craters, is essentially just a thin shell wrapped around a massive iron heart that barely fits inside. Mercury is, structurally, more iron than planet. Its core is the largest relative to planetary size of any known world in our solar system. Scientists confirmed this through data from Messenger, published in a 2019 study in the Journal of Geophysical Research, using variations in Mercury's magnetic field to infer the core's dimensions with extraordinary precision. And that raises an immediate and deeply unsettling question. Why? The leading theories divide into two categories, and neither is comfortable. The first idea holds that Mercury was struck by a massive impactor early in solar system history, not a head-on collision, but a glancing blow powerful enough to strip away most of the outer rocky layers, leaving behind the dense iron core inside. What you are looking at today would be the exposed heart of something that used to be far larger. The second idea, published in a 2021 paper, argues it was not a collision at all. It was the sun's own magnetic field during the solar system's formation, when the young sun was surrounded by a swirling cloud of dust and gas. Iron grains were drawn inward by magnetic forces. Planets forming closer to the sun incorporated more iron into their cores than those farther away. Mercury, sitting closest of all, accumulated iron at a rate none of the other terrestrial planets matched. Both explanations suggest the same thing, in different ways. Mercury is not simply a small planet. It is the survivor of violence or magnetism so extreme that what we see today is fundamentally not what was born here. Either the planet lost most of itself, or it was always this way, a world built on a foundation of iron with barely enough rock to cover it. And somehow, impossibly, that iron heart is still alive. The magnetic field should not exist. A planet as small as Mercury loses heat rapidly. Smaller worlds cool faster, and a cold core stops churning, stops generating a dynamo, stops producing a magnetic field. Mars lost its magnetic field billions of years ago. The Moon has none. Venus, Earth's near twin in size, has no global magnetic field either. Mercury, the smallest rocky planet, somehow maintained an active dynamo to this day. The field is weak, about 100 times weaker at the surface than Earth's, but weakness does not mean irrelevance, because Mercury sits where the solar wind is not a gentle breeze. At Mercury's distance, the stream of charged particles blasting off the sun moves with a ferocity roughly 5 to 10 times more intense than what Earth experiences, and Earth's magnetic field, strong as it is, still lets some of those particles through during solar storms. The result is our aurora borealis, beautiful curtains of light caused by electrons spiraling down magnetic field lines into the upper atmosphere. Mercury has no atmosphere to soften this. In October 2023, data from Bepi-Colombo's MEO spacecraft revealed something that went beyond strange. Mercury's aurora does not hang in the sky like Earth's. It touches the ground. Electrons accelerated through Mercury's magnetosphere crash directly into the surface, not into air, not into clouds, into rock. The planet's surface is being bombarded by radiation intense enough to ionize material and strip atoms away into space. The part that genuinely disturbs the researchers who study this is what it tells us about how quickly Mercury's magnetosphere responds to the sun. Because Mercury's magnetic field is so small and sits so close to the sun, the entire magnetosphere, the bubble of magnetic protection surrounding the planet, collapses and reforms on timescales of 1 to 2 minutes. 1 to 2 minutes. Earth's magnetosphere takes hours to respond to a solar storm. Satellites get warnings. Power grids get warnings. Airlines reroute flights over the poles. Entire industries exist specifically to monitor incoming solar weather, because we know how long we have before it arrives. Mercury gets 1 to 2 minutes. And there is no technology to warn, no life to protect, just rock, absorbing the full delivered force of a coronal mass ejection in less time than it takes you to read this paragraph. The surface of Mercury has been exposed to full solar bombardment like this on a near constant basis for approximately 4.5 billion years. 4.5 billion years of radiation striking the same rocks. 4.5 billion years of solar wind stripping atoms from the surface and flinging them into space. And yet, somehow, the planet still has ice, still has a magnetic field, still has something stirring deep beneath its surface. That tension between everything that should have killed this planet and everything that has somehow survived is what makes Mercury genuinely unsettling to the people who spend their careers studying it. And yet, Mercury has ice. Confirmed. Not hypothetical. Not trace amounts. Actual water ice. Sitting inside permanently shadowed craters near the planet's poles. The temperature on Mercury's sun-facing side reaches 430 degrees Celsius. Hot enough to melt lead. Hot enough to vaporize most metals over geological time. The night side drops to minus 180 degrees Celsius. A swing of more than 600 degrees between sunlight and shadow. The most extreme temperature variation on any planet in our solar system. But inside certain craters near the poles, where the geometry of the terrain guarantees the sun's light never reaches, the temperature is permanently locked near minus 170 degrees Celsius. And in those craters, Messenger found water ice, possibly hundreds of billions of tons of it. How it got there is still debated. Comets, asteroids, outgassing from the interior itself. But the water has persisted through billions of years of solar bombardment, tucked into permanent shadow, like a secret the planet has been keeping since before Earth had continents. A planet boiling on the outside, hiding frozen water in the dark. This is not the dead rock we assumed it was, but the most unsettling discovery, the one that rewrites the story completely, came not from a spacecraft mission, but from an algorithm. In January 2026, a team led by Dr. Valentin Bickel from the Center for Space and Habitability at the University of Bern published a study in Nature Communications, Earth and Environment. They had fed a machine learning system roughly 100,000 high-resolution images taken by Messenger between 2011 and 2015. The algorithm found 402 features that had never been systematically cataloged before. Bright, linear streaks running down the sun-facing slopes of young impact craters. Geologically fresh, meaning they had not accumulated the small secondary craters that older features collect over millions of years. Their edges were sharp, clean, new. They are called lineae. And the team's conclusion, after careful statistical analysis, was this: Mercury is still losing material from its interior. Today, when meteorites punch through Mercury's thin volcanic surface layer and into the volatile rich bedrock beneath, they open fractures, and through those fractures, sulfur compounds and other light elements, heated by the sun, vent upward. They flow down the crater slopes, leaving behind bright streaks of altered material. The planet is breathing out. Not dramatically, not violently, slowly, over decades or centuries, in ways too subtle for Messenger's instruments to catch between 2011 and 2015, but happening. Our findings paint a completely different, dynamic picture of the supposedly dead, dry, and boring planet Mercury. Supposedly dead. Mercury, The planet we had written off as a relic of 3 billion years ago is still subject to modification today. Which brings us to what happens next. Bepi-Colombo, a joint mission from the European Space Agency and the Japan Aerospace Exploration Agency, entered Mercury's orbit in late 2025. 2 spacecraft will operate for at least 1 year, studying the surface, the interior structure, the composition, and the magnetic field in more detail than has ever been attempted. But for the scientists working on Linnea, there is one specific and extraordinary experiment waiting. Bickle's team has mapped where every one of the 402 known streaks sits on the surface. Bepi-Colombo will photograph those same regions at higher resolution than Messenger ever managed. If new streaks have formed in the years since Messenger went silent in 2015, Bepi-Colombo will find them. If they have, it will be the first direct observational proof that Mercury is geologically active in the present day, not 3 billion years ago, not theoretically. Now, if they have not, then scientists must explain what mechanism produces these features and why the time scale is longer than a decade. Either answer is a discovery. Either answer forces us to rethink how we classify what a living planet actually is. Think about what Mercury represents for a moment. We live on a planet so large, so geologically violent, so geochemically complex, that we sometimes assume other worlds are only interesting to the degree that they resemble us. Mercury failed that test for centuries. Too small, too hot, too close to the sun. Not a place for life, not a place for wonder. But Mercury has been there the whole time, keeping its secrets behind a veil of proximity and solar glare, waiting for instruments sensitive enough to read its surface, patient enough to process 100,000 images, rather than just glance at a few. And what it has been keeping hidden is this: even the smallest, most damaged, most apparently lifeless world in our solar system is not finished yet. Its iron heart still churns, its surface still breathes, its ice still hides in the dark. The planet scientists called boring has a magnetic field that should not exist, ice that has no right being there, an interior that defies our models of planetary cooling, and bright streaks that may be evidence of geological processes happening right now. As you watch this, Mercury is not what we thought it was. It never was. The question is not what Mercury is hiding. The question is how many other worlds we have already dismissed too quickly, before we had the tools to really look. I hope this gave you a new way of seeing Mercury, the planet that has always been hiding in the sun's glare. If you found value in this, consider subscribing. I'll see you in the next one.